What if I told you your network is wasting 30 seconds every time you plug in a PC, and that your switches are making terrible routing decisions by default? In this video, I'll show you how to configure multiple VLANs with STP like a pro, optimizing route bridges for each VLAN, and using PortFast to skip those annoying delays. Watch now and transform your network from sluggish to lightning fast.
In this lesson, we will see how the spanning tree manages multiple VLAN. Here we have 3 switches, which have been reset to their factory settings. We will create VLAN 10, 20, and 30 on each of the switches. As by default, all the ports of a switch are in access mode, we will create the trunks between the switches. We choose .1q encapsulation, and we put the port in trunk mode on all the interfaces that connect a switch. The command show spanning tree summary provides a quick overview of topologies. Here we see that on switch B, all VLAN are in a blocked state. And if we use the show spanning tree command on switch C, we see that it has elected the route bridge for all the VLANs. Now that's not what we want. As the diagram indicates, we want each switch to be the route of a single VLAN. Currently, switch C is the route bridge for VLAN 10, 20, and 30. To do this, we will lower the priority of switches A and B for VLAN 10 and 20. We do not touch switch C or VLAN 30, since it is well elected the route bridge for its VLAN. On switch A, the command is launched spanning tree VLAN 10 priority 4096. By doing a show spanning tree VLAN 10, this time we can see that it is elected the route bridge. And we do the same on switch B, but this time on VLAN 20. Before, we only had the interface of switch C, which was blocked. Now we will have different blocked interfaces because we have a different route bridge for each VLAN. The show spanning tree command is very useful, as it provides all the information you need to analyze the operation of the spanning tree. Finally, we will talk about the different states that the port can have. Whenever you connect a cable to an interface, there are 15 seconds in listening and 15 seconds in learning, before being able to find yourself in the transfer function properly. In total, it will have spent 30 seconds before being fully functional. This operation is essential when you connect several switches to these ports in order to avoid loops. But what if you plug in a simple PC or any other terminating device? As this is end-of-chain equipment, in this case, it is not useful to listen to the BPDU, otherwise the PC would take 30 seconds before it can be used. To get around this, there is a Cisco proprietary solution, which is called PortFast. Interfaces with the PortFast mode activated will immediately switch to transfer mode, i.e. forwarding mode. It will therefore skip the listening and learning state. It is important to activate this mode on all interfaces that will be connected to hosts. The spanning tree PortFast command enables this mode. This command is to be passed directly on the interface conf. It is also possible to activate this function by default on all the ports of the switch. For that, it is necessary to execute the spanning tree PortFast default command in global configuration mode. And the last thing to see in spanning tree is the implementation of rapid spanning tree. At this point, it is not necessarily important to see in detail how it works, but just how to activate it. The command spanning tree mode Rapid PVST simply enables it. Convergence will then be much faster.